All right, let's check out knowledge check 12.5.7. Go ahead and load the Tidyverse package and get our Ames housing data. Okay, so number one, it says analyze the relationship between the quality features and sale price. Which of these features appear to have a relationship? Well, we could do this one-off. Well, first of all, let's do this. Let's look at Ames, and I want to select the sale price, and then I want to get all the quality features. And so we can see a pattern here. All the quality features tend to end with underscore qual. So I could go ahead and just say ends with qual, or if I want to be specific and say underscore qual. Then we can get sale price along with all the quality features within our data set. Now we could do just a one-off plot where I say, all right, I want to go ahead and plot, basically let's look at overall quality feature and sale price. And we could do a geom box plot here. Let's see. So we can plot that, and we can see that there's definitely a trend here. As the quality of the feature increases, then we can see that the sale price also increases as well. Now we could do this for each of our features. So I could go back and I could say, let's look at the kitchen quality. And do we see a trend? Well, in this case, we have excellent, fair, good, poor, and typical. And we could do one-off. Now, another way we could approach this is we could try to plot all this information at once. And to do that, right, recall that we have these variables once we've kind of down selected our features of interest. And what we could do is we could do pivot. I want to pivot this to be longer. And I'm going to say, well, I want to pivot all the quality feature variables, which would be everything except for sale price. And I'm going to say names to, so I'm going to say quality feature and values to, and I'm just going to call this rating, right? So what do I do here? If I run this, we can see we have each home sold and we have our sale price, and then we have basically our quality feature and the rating. So now we have made our data frame longer, and we have duplicated our observations. So it says sale price 215. We have overall quality, and then the rating, the exterior quality, the rating, the basement quality, the rating, and so on. What this allows me to actually do is I can go ahead now, go right into ggplot, and I want to plot the rating, so the actual quality rating on the x-axis, along with the sale price on the y-axis. And I'm going to go ahead and do a box plot. And then I can go ahead and actually facet this by the quality. And now that I have a space in between there, I can do quality feature. So now what happens, and this is a little tough to read right now, is I get basically a small multiple plot for each one of my quality ratings. So if I want to make this a little bit easier to read, I could do a couple things. I could say, first of all, I want to flip my coordinate value so I can now have my rating on the left-hand side, a little bit easier to read. Let's go ahead and say n columns is equal to 2. Oops. And there, and now it's just kind of condensed, so I can go ahead and make this a little bit longer, and it's a little bit easier to read. So now we can look through overall qual. We can definitely see a pattern here with the increasing in the sale price. And these other ones, not quite so much. We definitely see where the excellent ratings tend to be higher. But as far as the other trends that are in there, it's not quite clear. So we could say that there may be a trend across all the quality features where when they're excellent, you definitely get a higher price than when they're not. But I would say overall qual definitely has the most obvious pattern that as the quality increases to each level, we see an increase in the overall sale price. All right, let's jump down to number 2 here. It says assess the relationship between sale price, the ground living area, and the overall qual feature. How would you explain this relationship? So to do this one, we can just go ahead and do a plot where I want to go ahead and look at ground living area on the x-axis, and we'll do sale price on the y. And let's just do a scatter plot. So the default plot is this scatter plot that we've seen before. But now what I could actually do is I could say, let's go ahead and facet wrap. And I want to wrap by the overall quality feature. And now we definitely see a pattern that pops out. We see that from very poor in this first plot, it goes very poor to fair, all the way up to excellent and very excellent on the bottom. And we can see for each level, we tend to see basically that scatter plot move up diagonally. So it seems like we have the overall size of the home tends to increase along with the sale price. So that's a pretty interesting pattern. This basically implies that those homes that were rated very poor and fair tend to be, it looks like, smaller homes that obviously did not sell as high of a value as the larger homes that got rated good, very good, all the way up to excellent. All right, let's look at this last one. Which neighborhoods tend to have larger homes? Which of these neighborhoods have higher than average sale price and which have lower than average sale price? All right, so let's start answering these kind of piece by piece. So which neighborhoods tend to have larger homes? Well, an easy way to first look at that is we could just say, let's go ahead and we're going to group by neighborhood. And then I want to go ahead and summarize. And I'm just going to get the average. So let's just compute the mean of our square footage. And we can go ahead and arrange in descending order and average. So now when we do this, we can see which neighborhoods tend to have larger square footage. So let's do average square feet. And what I could actually do here is let me go ahead and add one more. Let's just do average sale price. And that's the mean of sale price. So we can get both of these together. And here we see basically the average square footage and the sale price for those homes. Now, if we wanted to get some more of this information plotting wise, what we can do is let's go ahead and geoplot or ggplot, and we're going to look at ground live area on the x-axis, sale price on the y-axis, and let's go ahead and just do a scatter plot. Again, here's our default plot. Now what we could do is add a facet wrap, and let's do this by neighborhood. And this is going to create a bunch of small multiples, one for each neighborhood. Let's go ahead and just do ncall equals 4. Right, so I could make this larger so it's easier to see. And we can definitely see which neighborhoods tend to have a certain relationship of higher square footage and higher sale price versus those that are lower of lower square footage, lower sale price, and you see some homes that have a lot of observations, and then some like Green Hills and Landmark, which we only have one or two homes that actually sold in those neighborhoods. Now we could build onto this, and it says, which of these neighborhoods have higher than average sale price? All right, well, one way we could look at this is we could say, let's color all those homes where the sale price is actually greater than the mean of Ames sale price. All right, what this is going to do is it's now going to color our points for those that are greater than the average sale price and those that are less. Now, this kind of makes it tough to see again. Let's go ahead and theme, and I think it's, let's see, legend. Where's legend position? And I want to just move this to the bottom of our plot. That makes it easier. There we go. So I can enlarge this again, take a look at this. And now we can start seeing which neighborhoods tend to have those that may have more homes that sold that were greater than the average versus more homes that were less. So for example, Northridge here has their points entirely in blue. And if you look at the legend, that means that all these homes that sold were greater than the average sale price across all the homes. Whereas, let's look at, south and west of Iowa State University. Most of those homes that sold were less than the average sale price. Now, another part of this question was to, let me scroll up here. It says, are there homes that appear to be much larger than the rest of the homes in the neighborhood? And actually, we can see that in this plot here. For example, look at Edwards. We have some points that are way over here, way outside of kind of the bunch of points that we have. And we can see that these homes had square footage of 4,000 and 5,000 square feet, much larger than the average, which looks like right around 1,500 square feet. So we can start looking at this plot and identify those homes that had outliers, maybe in the square footage, maybe they're outliers in the size of the homes, or some combination of the two.